Rationalizing is an important concept in, or whenever we have expressions that involve radicals. So, rationalizing simply means to get rid of a radical, either in the numerator or the denominator. So, we are going to rationalize denominators first. So, let's start with a simple example. So, here we want to get rid of the root 2 in the denominator. So what we do is we multiply and divide by root 2. So we would end up having square root of 3 times square root of 2 divided by square root of 2 times 2. We can combine the roots in the numerator also, which would give us square root of 6 divided by square root of 2 squared. The root and the square would vanish, and we would simply have square root of 6 over 2. And if you notice, the denominator went from root 2 to simply 2, which would imply that we rationalized the denominator. So here we have another example. We have square root of 2 over square root of 45x. And we'd like to get rid of the root in the denominator. So we multiply and divide by the square root of 45x. So the numerator now becomes square root of 2 times square root of 45x divided by square root of 45x times square root of 45x. So using the product rule, we could simply combine the roots in the numerator and write it as 2 times 45x divided by square root 45x times 45x is 45x, the entire thing raised to the power of 2. The root and the power would get cancelled, and we would simply have 45x in the denominator. In other words, the root disappeared. The numerator, we could write it as 90x. Now, is it possible for us to simplify? We can answer that question if we can write 90 in terms of factors that would give us a perfect squared. So the easy one would be 3 times 30, which is 90. Oh, excuse me. Which I could further write it as square root of 3 times 10x over 45. 3 times 3 is 9, so I could write that as 3 squared times 10 divided by 45. If we split the numerator, we have square root of 3 squared times square root of 30x over 45. The root and the square would go away, and we would simply have 3 square root of 30x over 45. But 3 and 45 can cancel, 15 times there, so we have square root of 30x over 15. And we successfully got rid of the root in the denominator. So now we have the cube root of 2 divided by the cube root of 25. In this case, if we want to get rid of the denominator root, we have a cube root. So what we have to do is we multiply and divide by the cube root of 25 one more time, so that would give us cube root of 2 times the cube root of 25 times the cube root of 25. The denominator, if we combine the roots and put it under a common root, we have 25 times 25 times 25. We could combine the numerator also, and we could write it as 25 times 25 times 2. Divided by the cube root of 25 cubed. So those two would go away. And we successfully got rid of the radical in the denominator. So we have cube root of 25, which I'm going to write it as 5 squared. 5 squared times 2 divided by 25. You may say, well, why is he doing that? Because I know that I could get a cubed of 5 out of the two 25s that I had. So I'm going to write 5 squared as 5 times 5. Now, 5 squared times 5 is 5 cubed. And 5 times 2 is 10. I'm going to split the root, so square root of 5 cubed times square root of 10 divided by 25. The root and the cubed would go away, which would give us 5 square root of 10 over 25. The 5 and the 25 would go away. We will end up getting, or they get cancelled, we'd end up getting square root of 10 over 5. So we successfully got rid of the radical in the denominator, and in addition, we simplified. So I could write in this problem square root of 7x over 3y as square root of 7x over square root of 3y. I would like to get rid of the root in the denominator, so I'm going to multiply and divide by the square root of 3y. So the numerator would now be 7x times 3y inside the square root, divided by square root of 3y times 3y, which is 3y squared. The root and the squared would go away, and we have square root of 21xy divided by 3y, and we successfully got rid of the root in the denominator. Keep in mind, rationalizing the denominator simply means getting rid of the root of some kind in the denominator. In short, we are getting rid of the radical in the denominator. So here is an interesting case. Every single problem that we did earlier simply had one term. But if we have in the denominator, but if we have two terms in the denominator, we can't simply multiply and divide by the numerator, by the denominator like we did previously. So here I looked at the denominator, it was square root of 3y. I multiplied and divided it by square root of 3y. But I can't do that here. In a problem like this, we multiply and divide by something called the conjugate of the denominator, which is 2 minus square root of 7. And why do we do it this way? We do it this way because the denominator has 2 terms. So that would give us 3 times 2 minus square root of 7 divided by 2 plus square root of 7 times 2 minus square root of 7. If we just FOIL and we simplify, we would simply end up getting 2 squared. In other words, that term squared minus that term squared. And the minus in the middle is important. You can verify this by foiling and you will get that particular expression in the denominator. So the numerator is simply 3 times 2 minus square root of 7 divided by 4 minus the root and the square would get cancelled. So we simply have 7 in the denominator. So the numerator is 3 times 2 minus square root of 7 divided by 4 minus 7, which is simply negative 3. So the 3 and the negative 3 would get cancelled, leaving us with 2 minus square root of 7 divided by negative 1, which is the same as negative 1 times 2 times the square root, negative 1 times 2 minus square root of 7, which if we distribute the negative inside, we end up getting 2 plus square root of 7. The answer is square root of 7 minus 2. We want to rationalize the denominator again. So the conjugate of the denominator is root 2 minus root 3 divided by root 2 minus root 3. So the numerator becomes square root of 3 plus 2 times square root of 2 minus square root of 3. Keep in mind, we can simplify like we did in the previous problem with the denominator if and only if the denominator is multiplied by its conjugate. So in the numerator, the 2 terms are not conjugates of each other. So what we have here is root 2 squared, the first term squared, minus the second term squared, the root and the square would go away, and we would simply have square root of 3 plus 2 times square root of 2 minus square root of 3 divided by 2 minus 3. I'm going to FOIL the numerator, and I would have square root of 3 times square root of 2 plus 2 times square root of 2 minus 2 times square root of 3 minus 3 times square root of 3. The denominator is negative 1. So I will have square root of 6 plus 2 square root of 2 minus 2 square root of 3 minus 3. Oh. Excuse me, I sort of made a mistake here. Going one step ahead. So the first term would be square root of 3 times square root of 2. Then we have square root of 3 times square root of 3 plus 2 times square root of 2 minus 2 times square root of 3 divided by negative 1. If I combine the first set of roots, 3 times 2 would be 6. The second, we have 3 times 3, which is 3 squared, plus 2 root 2 minus 2 root 3 divided by negative 1. The root and the squared would go away, which would give us root 6 minus 2 root 2 minus 2 root 3, plus 2 root 2 divided by negative 1, which is the same as saying negative 1 times square root of 6 plus 2 root 2 minus 2 root 3. If we distribute the negative, we have negative square root of 6, negative 2 root 2 plus 2 root 3. I'm going to write this as 2 times root 3 minus 2 times root 2 minus root 6. And you can see that I've successfully gotten rid of the radicals in the denominator. Now we're just going to do the opposite of what we did previously. We are going to rationalize the numerators. So we have to multiply and divide by whatever we see in terms of the root in the numerator. So here I see square root of 12 in the numerator, and my goal is to get rid of the root. So I'm going to multiply and divide by square root of 12, which here is the numerator. So the numerator now becomes square root of 12 times 12, which is 12 squared, divided by square root of 7 times 12. The root and the square would go away. We have 12 divided by 7 times 12 is 84. But before we get there, we need to ask the question, could we simplify the denominator further? Well, that we can answer if we could write 12 in terms of a perfect squared. So we can write that as 7 times 4 times 3. So which would equal to 12 divided by square root of 7 times square root of 4 times square root of 3, which is 12 divided by square root of 7, square root of 4 is 2, times square root of 3. Now, the 2 and the 12 would get cancelled, and we would get 6 there. So 6 divided by square root of 3 times square root of 7, which is 6 over square root of 21. So we got rid of the radical in the numerator. Keep in mind, oftentimes, always, if you try to rationalize the denominator, you can't get rid of the numerator radical. If you try to rationalize the numerator, you cannot get rid of the radical in the denominator. So at any given time, we could either rationalize the numerator or we can rationalize the denominator. So here I want to get rid of the radical in the numerator, So I'm going to multiply and divide by the root in the numerator. So I would get square root of 3 times 3 is 3 squared, divided by square root of 2 times 3, which is 6. The root and the square would get cancelled, and we would simply have 3 over square root of 6, and we successfully got rid of the radical in the numerator. So here we have an expression. In the numerator and the denominator, we have 2 terms. Our objective here is to rationalize the numerator. So the conjugate of the numerator expression is square root of x minus square root of y. Keep in mind, if we have x here, plus there, the conjugate would have a minus. That's why we call it the conjugate. It is an opposite. So we're going to multiply and divide by square root of x minus square root of y. And if we have this setup, we know from previous examples, I could simply write it as square root of x squared. Square root of x is the first term. The minus in the middle is important. Square root of y squared, that would be the second term, divided by square root of x minus square root of y. Since those 2 terms in the denominator are identical, I could simply combine them and write it as square root of x minus square root of y whole squared. So the root and the power would get cancelled there, the root and the power would get cancelled there, and we would simply have x minus y divided by square root of x minus square root of y squared, and we successfully got rid of the radical in the numerator, so we have rationalized the numerator.